So Maxwell applied divergence to this equation 3. Divergence of a curl is equal to 0. So we have here this equation, divergence of a curl is equal to minus divergence of dou b by dou t, and he found that LHS is 0, RHS is 0. That is, divergence of curl is equal to 0, RHS is also equal to 0, and this is a valid equation. Means there was no problem. So Faraday's law was correct. First three equations were correct. Maxwell didn't find anything wrong with these three equations. So what he did, next step he did is that he applied divergence to the Ampere's law. Now, when he took the divergence of the equation 4, that is Ampere's law, what he found is that the LHS is a divergence of a curl B, and RHS we have a divergence of a J, but divergence of a J is not equal to 0. LHS is equal to 0. So LHS is a 0, but RHS is not equal to 0, and this was an inequality. The LHS becoming 0, left hand side divergence of a curl B is equal to 0, and the RHS divergence J is not equal to 0. Therefore, the RHS was not equal to 0, LHS was equal to 0, and this inequality existed. Now the scientist Maxwell observed this inequality and used the equation of continuity and Gauss law to correct the Ampere's law. Now how did he correct? Now already, as we know, he applied the divergence to the curl of equation. So he had already divergence of a J. He was already having divergence of a J. So he used the equation of continuity. What is equation of continuity? Divergence J plus d rho by dt is equal to 0. What he found is that del or divergence J is not equal to 0. But if we add some term additional here, it becomes equal to 0. Means divergence of a J is not equal to 0. But if you add an additional term d rho by dt to this equation, it is becoming 0. So he thought that why not to add some additional term according to equation into this equation? Because what he found, divergence J is not equal to 0. But if we add a certain amount to this, it is becoming 0. That means we need to add some correction to this equation, that above equation. This was the thought in the mind of the Maxwell. So for that purpose, he simplified this equation. Divergence J, this is taken from left hand side to the right hand side, it became minus. So divergence J is equal to minus d rho by dt. Then again here rho was there. Now as already we know the value of this rho from this equation, that is the divergence is equal to rho divided by epsilon 0. So Maxwell took the value of a rho from this equation, that is, if we take the epsilon 0 to this side, epsilon 0 del dot E is equal to rho. As we already know, epsilon 0 is the permittivity. Permittivity of, here it is a 0, so it is a permittivity of free space. That is basically having the value 8.85 into 10 raised to minus 12. And it is the ability of the electric field to store the electrical energy. Now, the value of rho is epsilon 0 del dot E. So Maxwell put this value in this equation. Rho epsilon 0 del dot E. And again is simplified. Del dot J is equal to epsilon 0 is a constant. It is taken outside the derivative. So minus epsilon 0. And divergence also we can interchange these are the derivatives. We can change the derivatives. Means this is a derivative with respect of space coordinates x, y, z. This is a derivative with respect to time t. We can alter the derivatives. So he altered the derivatives. Divergence he has taken. Now he has the term dou E by dou t. Now this RHS, it has been taken to the right hand, the left hand side. So here it was a minus, it became plus. The other terms as it is. So we have this equation simplified as divergence J plus epsilon 0 dot del dot, means the del dot means the divergence of dou E by dou t, that is equal to 0. Now Maxwell took the divergence as separate, common, because here it was a divergence, here it was a divergence. He took the divergence into as a common, and he has taken it outside the bracket. Now remaining terms he closed in one parenthesis. What were the remaining terms? J plus the remaining terms here, epsilon 0 and dou E by dou t. So J plus epsilon 0 dou E by dou t. So epsilon 0 dou E by dou t, he termed this term, this termed as the displacement current density JD. He termed this term as the displacement current density. So divergent J plus epsilon 0 dou E by dou t instead of this term, because this is one equation. This term must have the dimensions of current because we are adding two currents. We cannot add current and voltage together. We need to add current to the current. That means this term must have the dimensions of current. He thought like that, and he termed this as a displacement current JD. He added to this equation, and he has a modified equation as divergent J plus JD is equal to 0. Now, where JD is the displacement current density. Now, what he thought? Maxwell thought that why not to add the term epsilon 0 dou E by dou t with J in Ampere's law. So, right hand side will become, right hand side of the Ampere's law, that is a fourth equation, that will become epsilon mu 0 J plus mu 0 epsilon 0 dou E by dou t. As we know that this is the permeability. Mu 0 is the permeability of free space. It is the ability of the material or any substance to allow the magnetic lines of force to pass through it. So, permittivity is the one thing wherein we have storage of electricity, to storage of electrical energy in the electric field. And permeability is the other term related to the magnetic field. It is the permeability is nothing but the permission to the magnetic lines of force to pass through a substance. That's all. This is the permeability. And then we have a permittivity. Now, Maxwell thought that the right hand side of the fourth equation, that is Ampere's law, must look like this. Mu 0 J plus mu 0 epsilon 0 dou E by dou t. Such a modification changes as per magnetostatics. He made these changes. Now, when you go to the magnetostatics, static means it is stationary with respect to time t. Animal, dou E by dou t will be equal to Annapurna.
हाँ सर.
Can you switch off your mic?
काय सर?
Can you unmute? Mute. Now, when you go, this is a case because this is a time variable. This is a dynamic case. Now, when you go to the static case, suppose this is a static case, E doesn't depend upon T. When this is E doesn't depend upon the T, the derivative of E with respect to T is equal to 0. Derivative of E with respect to time T is equal to 0. Now, we don't have a problem because this is related to the electrodynamics. Here, the start of the electrodynamics happened when Maxwell corrected the Ampere's. And this equation, this is called as a Maxwell's correction to the Ampere's law, and it signifies that change in the electric field induces a magnetic field. Magnetic equation. Change in electric field induces a magnetic field. That's all. And as we already discussed, Maxwell termed this extra term as a JD is equal to the epsilon 0 dou E by dou t, that is a displacement current. Now, next. Now Maxwell, when he observed this, he has a 4 equations. As I told you, in electrostatic we have a Gauss law, magnetostatics we have a Gauss law, we have a Faraday's law, and the 4th equation was Maxwell's correction to the Ampere's. 3 equations he took as it is, and the 4th equation he corrected. Now, as Maxwell was having these 4 equations, each equation has some significance. Now, this is the significance. What is significance? First equation, now these are the Maxwell's equations. Initially we considered them as Gauss law in electrostatics. Now we will term it as a Maxwell's equations. Now, what is the first Maxwell's equation? Del dot E is equal to or divergence. इथं कधी कधी काय असतं डॉट असतो. डॉट असला की डायव्हर्जन्स म्हणायचं आणि डॉट कधी कधी नसतो. डॉट नसला की त्याला ग्रेडियंट म्हणायचं. डॉट असणं म्हणजे त्याचा डॉट प्रोडक्ट घेतो आपण, स्केलर प्रोडक्ट घेतो. डॉट जेव्हा नसतं तेव्हा आपण त्याचा डेरिव्हेटिव्ह घेतो डायरेक्ट. आता मागच्या इक्वेशन मध्ये तुम्हाला लक्षात येईल इथं काही डॉट नाही, डी बाय डी टी डायरेक्ट घेतलं. दिस इज अ सिंपल डेरिव्हेटिव्ह. आणि इथं काय घेतलं डॉट प्रोडक्ट घेतलं आपण. सो दिस इज अ स्केलर प्रोडक्ट ऑफ टू वेक्टर्स. डेल इटसेल्फ इज अ वेक्टर, x cap dou by dou x, y cap dou by dou y, z cap dou by dou z its value. आणि दोन वेक्टरचे स्केलर प्रोडक्ट जसे की a आणि b जर दोन वेक्टर्स असतील we term it as a ab cos theta. The dot product of a dot b is equal to ab cos theta. And cross असेल तर we consider it as a cross b is equal to ab sin theta. Like that, cross product. Now, Maxwell first equation was del dot E is equal to rho divided by epsilon 0, and it was having certain significance. The divergence of electric field is equal to the charge density inside the closed surface of interest multiplied by a constant. But the significance, this is a very important part. When you go to the net set examinations, when you go any competitive examinations, or even if you go to the interview, they will ask you what is the significance of Maxwell's equation. You should know the significance of Maxwell's equation. What it signifies? The divergence of electric field is equal to the charge density inside of a closed surface of interest multiplied by a constant. What is that constant? Constant is 1 by epsilon 0. तुम्हाला वाटेल तर डिवाइड केलंय, but it is multiplied by 1 divided by epsilon 0. This is basically the term that is multiplied by constant. The divergence of electric field is equal to charge density inside the closed surface of interest multiplied by a constant. The divergence is how much the electric field spreads out from a given point. The divergence is how much the electric field spreads out from a given point. If there is a more change inside the divergence, if there is a more charge, or if there is more charge inside the arbitrary surface or closed surface, then you will have a greater divergence. If it is if there is no electric field, if there is no charge, the divergence will be equal to 0. But the most important thing you should keep in mind that the divergence of electric field is equal to charge density multiplied by the some constant. That's very important. Now the second Maxwell's equation, del dot B is equal to 0. Now this signifies that there are no magnetic monopoles. Why this is happens? Del dot B is equal to 0. There do not exist magnetic monopoles. तुम्ही बार मॅग्नेट बघितलं, समजा एक हा एक बार मॅग्नेट आहे समजा, किंवा if you consider this as a bar magnet, if I go on cutting this bar into pieces and pieces, आपण बार मॅग्नेट घेतला तर ह्या बाजूला पण टाचणी अटॅच होते, ह्या बाजूला पण अटॅच होते, पण one side is a north pole and other side is a south pole. समजा मी याचे कट केले, दोन भाग केले, समजा मी याचे दोन भाग केले. फॉर एक्झाम्पल आपण घेऊ, समजा हा एक मॅग्नेट आहे, मी याला कट केलं आणि कट करून याचे समजा दोन पीसेस केले, दोन पीसेस केले. म्हणजे काय, माझ्याकडे अगोदर एक बार मॅग्नेट होता. आय हॅव वन बार मॅग्नेट. Suppose that this is the north pole, this is south pole. If I cut into this into two pieces, you will have two pieces. आणि मग याच्यामध्ये हा साऊथ असेल आणि हा नॉर्थ असेल. त्या दुसऱ्या पीसला पण तसा असेल, नॉर्थ साऊथ असेल. म्हणजे काय, इफ यू गो ऑन कटिंग द पीस ऑफ द मॅग्नेट, magnetic dipoles are generated. Single, जसं की तुम्ही म्हणता, let us consider an electron. Single charge is possible, but single magnetic pole do not exist. That is, there are no magnetic monopoles. This is the significance for the second Maxwell's equation. Now the third equation was a Faraday's law. Now Faraday's law, curl is equal to minus dou B by dou T. That is, the curl of electric field is equal to negative of the time derivative of magnetic field in time. बघा काय म्हणतो. This is the third Maxwell's equation, which is basically Faraday's law. Curl is equal to minus dou B by dou T. The curl of electric field is equal to the negative of the time derivative of magnetic field. The curl of electric field is equal to the negative of the time derivative of electric field in time. In other words, if the magnetic field isn't changing, electric field lines are straight. The electric lines of force जे असतात अशा असतात पॅरलल एकमेकांना. आता त्या लाईन्स ऑफ फोर्स सरळ जातात, पण मध्ये जर मॅग्नेटिक पोल्स आले तर असं होतं. तुम्ही जर कंडेन्सर मॅटर फिजिक्स मध्ये मायझनर इफेक्ट बघितला असेल सुपर कंडक्टिव्हिटीचा, त्याच्यामध्ये आपण असं करतो डायमॅग्नेटिकला असं असं सरळ असतात आणि पूर्ण त्या सुपर मॅग्नेटिक मटेरियल आले की असं होतात, बेंड होतं. मग जर समजा suppose magnetic the curl is equal to minus dou by dou t. If there is no magnetic field, there will not be, or the electric lines of force will be a straight lines of force. The curl of electric field is always equal to negative of the time derivative of the magnetic field. This is the third Maxwell's equation. Now त्यालाच आपण असं म्हणतो अजून एका गोष्टीला, a changing magnetic field can induce the electric field. A changing electric field, a changing electric field, or sorry, changing magnetic field can induce the electric field. Changing magnetic field can induce electric field. जसं मी तुम्हाला सांगितलं हायड्रोइलेक्ट्रिक असतं, तिथं पाणी पडतं टर्बाईन वरती. When water falls on the turbine, turbine rotates. When turbine rotates, turbine is in the magnetic field. When turbine rotates, the magnetic lines of force are cut. Continuously it goes on cutting. There is a change in the magnetic field. And when there is a change in the magnetic field, according to the Maxwell's equation, the electricity is generated. Windmill मध्ये तेच असतं, परळीला थर्मल पॉवर प्लांटला तेच आहे, तुमच्या कोयना डॅम मध्ये तेच आहे. So this is the basic idea. This is the basic logic in the generation of electricity. Now the next law is the Ampere's law, along with Maxwell's correction, of course. Curl B is equal to mu 0 j plus mu 0 epsilon 0 dou E by dou t. This is the Maxwell's fourth equation. Curl B is equal to mu 0 j mu 0 epsilon 0 dou E by dou t. The curl of the B is equal to the current density plus any change in the electric. Very simple. Curl of B is equal to current density plus any change in the electric field. And this second term is often termed as displacement current, since it helps in dealing with capacitors. Charging, discharging जे बोलतो आपण capacitors तिथं आहे. So these equations, del dot E is equal to rho divided by epsilon 0, del dot B is equal to 0, then we have a curl E is equal to minus dou B by dou t, then we have a curl B is equal to mu 0 j plus mu 0 epsilon 0 dou E by dou t. This four equations altogether form a system or that supports the classical interaction between electric charges and current in the system, and they are called as a Maxwell's microscopic equations. इथे लक्षात ठेवायचं आपण, इथे जिथे जिथे epsilon 0 आलाय, mu 0 आलाय, this is a microscopic form. This is a microscopic form. म्हणजे इथे जे आहेत आपण घेतलेले बघा, इथे मायक्रोस्कोपिक घेतलोय एका बाजूला आपण, डेल डॉट ई del dot b. इथं काय झालं, epsilon 0 आलं. इथं we have the term epsilon 0. इथं mu 0 epsilon 0 term आली. हे मायक्रोस्कोपिक फॉर्म मध्ये. ह्या epsilon 0 ला if we convert these equations into if you convert these equations into macroscopic form, just a moment. Okay. Macroscopic form. कसे convert करू शकतो आपण? Here we used these two things. Correct. I had a doubt here, but okay, it's fine. So the macroscopic field equation, म्हणजे हे basically microscopic and macroscopic आहे. Microscopic, this is basically applicable to the vacuum. This is applicable to the free space. जिथे काही material substance आहे, air आहे, free space आहे, we can use the microscopic form. Vacuum आहे, we need to use the microscopic form. म्हणजे इथे जिथे जिथे हे ज्या टर्म्स येतात, epsilon 0 mu 0 जिथे जिथे टर्म येते, we call it as a Maxwell's equation in microscopic form. मग macroscopic form मध्ये कन्वर्ट करायचं असेल तर काय करावं? We need two equations. What are those two equations? Let us see. D is equal to epsilon 0 E and mu is equal to H. Here it should be H. H is equal to B divided by mu 0. These two things are very important. What is a D? Dielectric displacement vector. Now what is a H? H is nothing but the intensity of magnetization. H is this mu is of course this should be H. Okay, so this is a H and this is a D. D is equal to epsilon 0 E, and here we have H is equal to B divided by mu 0. Let us proceed further. आता इथं D ची किंमत माहिती झाली आपल्याला epsilon 0 E. आता आपण जर समजा ह्या मायक्रोस्कोपिक फॉर्म मधलं हे epsilon 0 इथं घेतलं, इथलं epsilon 0, माऊसची पोझिशन दिसते का माझ्या? Anybody?
Yes, sir.
epsilon 0 जर इथं घेतलं तर आपल्याला असं इक्वेशन येतं डेल डॉट epsilon 0 E किंवा डेल डॉट E epsilon 0. आता इथं काय epsilon 0 E ची किंमत we have used it as a D, dielectric displacement vector किंवा त्यालाच electric displacement म्हणतो आपण. मग काय येतं? Let us substitute this value of D here. ते येतं del dot E is equal to del dot D is equal to rho. This is the first Maxwell's equation in macroscopic form. बघा फक्त काय केलं आपण D is equal to epsilon 0 E substitute केलं. इथे किंमत टाकली ह्या इक्वेशनला सिम्प्लिफाय केलं del dot epsilon 0 E is equal to rho. epsilon 0 E ची किंमत D टाकली. Del dot D is equal to rho. This is the first Maxwell's equation in macroscopic form. Second equation काय आहे? Del dot B is equal to 0. That equation is kept as it is. Third equation, curl is equal to minus dou B by dou T. याच्यात पण कुठे epsilon 0 mu 0 ची टर्म आली. म्हणजे हे जे दोन इक्वेशन्स आहेत del dot B is equal to 0 and curl is equal to minus dou B by dou T remains same. There is no change. Only first equation del dot E is equal to rho divided by epsilon 0 is changed to del dot D is equal to rho. Two equations remain as it is, no change. And the third equation, fourth equation, curl B is equal to mu 0 J plus mu 0 epsilon 0 dou E by dou T. आता इथं टर्म आली बघा, mu 0 एकदा आलंय, इथं mu 0 आलंय, इथं epsilon 0 आलंय. Let us take this mu 0 to this side. काय होईल मग? इथं काय होईल? डिवायडेड बाय होईल, B divided by mu 0. आता इथं B divided by mu 0 होतं आपल्याला, त्याची किंमत आहे H. We can substitute that value. म्हणजे एक स्टेप केली आपण, ह्या mu 0 ला इकडे घेतलं, ह्यावर कर्ल B divided by mu 0 is equal to J plus dou by dou T epsilon 0 E. मग आता इथे epsilon 0 E ची किंमत D ठेवा, B divided by mu 0 ची किंमत H ठेवा. So we have substituted curl B divided by mu 0 as a curl H. इथं J राहिलं as it is, mu 0 इकडे गेलं, हे mu 0 इकडे गेलं, J plus epsilon 0 dou E by dou T. Dou E by dou T ची किंमत ठेवली आपण, epsilon 0 E ची किंमत ठेवली D. So we have a curl H is equal to J plus dou D by dou T. And as already we know, this term is always termed as a displacement current density. So J plus JD, where JD is equal to dou D by dou T. Now these are the four equations, Maxwell's four equations in terms of the macroscopic form. Microscopic and macroscopic लक्षात कसं ठेवायचं? जिथे epsilon 0 येतं, जिथे mu 0 येतं, that is the microscopic form. जिथे epsilon 0 येतं, जिथे mu 0 येतं, that is a free space आणि vacuum applicable equations असतात, that is called as a microscopic form. आणि macroscopic is nothing but where these terms do not appear. Epsilon 0 येत नाही, mu 0 येत नाही, किंवा epsilon येत नाही, mu येत नाही. काय येतं मग? We have the conversions, D is equal to epsilon 0 E with substitution del dot D is equal to del dot D is equal to rho. First Maxwell's equation macroscopic form. Second equation, third equation as it is. चौथ्यामध्ये if you take the mu 0 to the LHS, it will become divided by B divided by mu 0 is a H. Make it as a curl H. Mu 0 goes here, J remains, and epsilon 0 is nothing but dou D by dou T. So the curl H is equal to J plus dou D by dou T. Is the fourth Maxwell equation in macroscopic. So we have the equations. Divergence is equal to rho divided by epsilon 0. Divergence B is equal to 0. And then we have a curl E is equal to minus dou B by dou T, Faraday's law, our third Maxwell's equation. And then we have a curl B is equal to mu 0 J plus mu 0 epsilon 0 dou E by dou T, the fourth Maxwell's equation. These are the microscopic form of the equations. And the second thing is that we have a macroscopic form. In the macroscopic, we have a del dot D is equal to rho. First equation. Second equation as it is, del dot B is equal to 0. The third equation, curl is equal to minus dou B by dou T as it is. And the fourth equation, again, there is alteration, and that becomes curl H is equal to J plus dou D by dou T. So this group of equations, 4 equations together, are called the Maxwell's equations. Maxwell published these equations, and he received the Nobel Prize for these equations. So this was our first point. Maxwell's equations in revision basically related to the Maxwell's equation, microscopic and macroscopic form that we have finished today. Tomorrow we'll have the thing which is related to the wave equation. For a moment, you switch on your videos so that I can record your attendance. Be fast. Slow it one zara. करा सगळे पटपट करा. इस तरीके ना आज गीतांजलि, अन्नपूर्णा, प्रशांत, शुभांगी, ओम प्रसाद, संध्या, लिहू लागले बघा. अटेंडन्स होणार नाही बरं तुमची. कमी झाले वाटायला लागले. मग आहेत 20, कमीच व्हायला लागले वरचीवर. माझ्यासाठी नाही, तुमच्यासाठी तर व्हिडिओ ऑन करत जावा. आता समजा ज्यांनी मैत्रिणी आहेत समजा त्यांच्यासाठी तर किनारीला तिकडे करमत नसेल ना, इकडे सगळे सोडून वैष्णवीला सोडून मैत्रीण. होय किनारी का करमताय? फास्ट करमतंय का?
नाही सर.
करमेना झालंय. तुमचं तर रेड झोन मध्ये आहे कंधार.
हो सर.
वैष्णवी कुठे आहे?
काय सर?
मला करमतंय काय म्हणून मैत्रिणीला सोडून?
करते ना.
पुढचं लेक्चर कोणाचं अटेंड
करमत.
हो हो. उद्या 8:30 ला जॉईन हो. ठीक आहे. करू एंड. बघू आपण किती एंड होते का आपोआप बघू.